Okay, so then the material property here is analysis, explicit analysis with 3D stress, and we have to select this element deletion, yes, that once the material damaged, it should be deleted. Or then that allows the system not to overlook the deleted element with undeleted element, or damaged element with undamaged element should not over one cross over another. That produces spurious deformation or false result in our work. So in order to avoid those things, we select this. So finally, C3D8R, that is 8 nodes linear brick reduced integration, hard gas control is selected. Okay, so this is the mesh type. So we use this type of mesh. Finally, the model is run and successfully completed because I followed all steps in proper manner, so that there is no error on that. That's why it is completed. So then let's see the result of this model. Okay, so this is undamaged mesh or plot undeformed shape. Okay, this is the shape when it is deformed. Okay, so this is a deformed shape. And also plot contour on deformed shape. We can see the contour plot of deformed shape. And at the same time, we can simulate the model. Let's simulate it and let's see what happened. So this is the simulation. Okay, this is the simulation. You can observe the exit and the entry of the bullet in this manner. Yeah, this is the damage pattern. Okay, so let's see the deformation. This is a deformation, U3. What about U2 and the U1? They are not, because U1 and the U2 are less suffer. So it is most deformation on U3 direction. Okay. And what about the stress? Let's see, this is by default, that is von Mises stress contour. So let's see stress 1 contour, stress 2 contour, stress 3 contour, and others also. Okay, so what about the this? Let's see future age. Let's see. Yeah. So we can model it one by one. The interested one will follow me. So this is okay now. So exterior edge. By default, it is in exterior edge, so that's why. Okay. Yeah, so let me share you the model from the very beginning. Let me start modeling a new one. This is this is already pre-created one, so it might not give you an appropriate knowledge. So let me go to new model. Okay, share. Okay, new window. Share. Yeah, this is new window. On that, I will start from the scratch. Okay, the first thing is creating a plate. So create part. So the name of plate is steel plate. Steel. 3D deformable solid extrusion option is selected. And then take a rectangle, create a rectangle, sorry, and create dimension of 100 millimeter by 100 millimeter. So this is the plate. Actually, we can bring the plate into middle. Anyways, let it be there. And the thickness of the plate is 2 millimeters. Okay, so this is the plate. Let me create partition on the plate in order to identify critical regions and the less critical region. So let me make partition. I'll create the model very quickly, so please pay attention. Okay, let this be critical region. Sorry, okay. And let me extrude this thing through the thickness of the plate. Extrude along the direction. Okay, done. Create partition. Done. Now this part having two sections, the inner critical region and the outer less critical region. Okay, now let's create another part, that is an impactor. So an impactor is a discrete rigid impactor. I need the discrete rigid from shell revolution. Let me use this option. Okay, so for this, let me simply take the dimension, that is diameter 10 means radius 5, and then let's take this model as the model for bullet, and let's remove unnecessary edges. Someone can provide some grooves and other things as much as he needs. Okay, this is the geometry and 360-degree rotation. 360. This is considered as a bullet. Okay, we have two parts. One is the bullet and another one is the plate. So let's assign a reference point for the bullet. Let me assign a reference point at this point. Okay, so we can see RP, that is a reference point. So I will provide mass as well as velocities through this reference point. And then the next is go to property. Then in the property, for the bullet, the only property that I can provide is the mass here. Okay, so mass property of the bullet will be assigned. So special inertia, create point mass. Okay, through this reference point. Okay, now that is the mass is 100 gram. Okay, 100 gram of mass is already given. The next part is a steel part. So steel part, the properties required are, let me give the name, steel. Okay, general density, which is equals to 7.8 E minus 9, which implies it is ton. Instead of kilogram, we use here ton. So it is ton per millimeter cube. So that is 7.8. The next is elasticity. Isotropic material property, because steel is homogeneous isotropic material, it has 210,000 megapascal youngest smoothness and 0.3 Poisson ratio. And the next is plasticity. Plasticity, plastic. So we have to provide the yield stresses at various points and the corresponding plastic strains, because this plasticity is one of an important part because this thing will take place some strain rate effect. So let's give some values from experimental that is already given in the previous lecture. So let me provide these values: 750 at 0 plastic strain, 800 at 0.001, sorry, 01, okay, 820 0.02, 839 0.1, 890 0.16, 920 which is correspond to 4546, okay, 950, it is in megapascal actually, 1, and 1120. There are some values also, 4.2. This is taken from experimental setup. And the next is once we can go for damage for ductile material, ductile damage. On this ductile damage, we have to define fracture strain, stress triaxiality, strain rate. So this should be defined. So fracture strain 1, 0, and strain rate, the second 0.6, 0.39, and 30. And then the damage evolution should be specified through displacement at failure point. That is 0.022 is taken. So these are the material properties for particular steel. Okay, let's assign this property. Okay, section, steel section, homogeneous. Okay, and then assign the section. Yeah, this is the steel section. The only program from impactor is only mass. So mass is already assigned, and we can see here a green color that implies the mass of impactor. Okay, what is the next? Let's go to assembly. Okay, then create an instance. Here, part 2 is the bullet. Sorry, we can change the name. First, let me change the name of bullet. Here we have 2 parts. Okay, let me rename this part. That is bullet. Okay, so bullet and steel. Let's assemble them. Okay, okay, a steel plate. Apply bullet. Let them be separate. Okay, so these are the 2 instances. And translating bullet from this point or from some point here to the center of the plate. Okay. Now